Hello everyone, I'm Rishabh Patel, and in this video I will talk about what's inside a PC. So the goal of this video is to inform users who are getting started on building a custom PC of what kind of components are inside a PC, and also what kind of custom PCs you can build using those components. And if you're actually interested on how to build your own custom PC, I will attach a document in the video description. So the document is a step-by-step instruction guide which will give you step-by-step instructions on how you can build your own custom PC. So the first component inside our PC is the CPU. So CPU stands for Central Processing Unit, and it acts as the brain of the whole system. It's also the most important part inside our PC. So the CPU is responsible for performing all kinds of calculations such as logical operations or arithmetic operations. So let's say, for example, you press a key on a keyboard or you navigate on a screen using a mouse. So at these instances, the CPU is being fed with billions of instructions that it has to execute. So the speed of a CPU is rated in terms of gigahertz, which means that the CPU can execute billions of instructions per second. As you can see that whenever I press a key or whenever I'm moving the mouse, the actions are almost instantaneous. It's mainly because the CPU can execute billions of instructions per second. So what I have here in front of me is how a CPU looks on the outside, and this is how a CPU looks on the inside. So this particular CPU is a 4-core CPU. This is core 1, core 2, core 3 and core 4. So the CPU also has a memory controller. The memory controller is responsible for connecting memory on the CPU, which is the shared L3 cache, to the memory that's outside the CPU. We will talk about memory that's outside the CPU in a few minutes. So next up we have the PCIe. The PCIe is responsible for connecting the hardware devices that's outside the CPU to the components that's inside the CPU. Same goes for the miscellaneous I/O. It basically connects the input-output devices that's outside the CPU to the components that's inside the CPU. So next up in our custom PC is the motherboard. So the motherboard is responsible for connecting all the PC components to each other. So in a sense it acts as a custom PC's main circuit board. So it's responsible for connecting the processor or the CPU, the memory, the graphics card and other input-output devices to each other. So here's how a motherboard actually looks like. So this is the processor socket. So this is where you essentially place the CPU. Right here we have the memory slot. So this is where you place the RAM sticks. And this is the AGP slot. So the AGP slot is where you actually house the graphics card. And for the PCI slots, they can be useful if you want to have expansion cards such as a sound card or an expansion card for USBs. We also have a SATA slot. So the SATA slot is responsible for connecting hard drives to the motherboard. And then we also have a BIOS switch. A BIOS switch is used for booting into the BIOS of a motherboard. And so lastly we have a north bridge and a south bridge. So both of these bridges in modern day motherboards are combined into one chipset. Basically they're responsible for connecting other components to the motherboard. So the next component in our PC is RAM. So RAM stands for Random Access Memory, and it acts as a PC's short-term memory. So like we talked about before, that the CPU is responsible for performing all kinds of calculations. So whenever the CPU is performing those calculations, it needs the physical medium to store data and to read data from. So the RAM acts as a physical device for the CPU to store data and to read data. The RAM acts as the PC's short-term memory in a sense that the data stored in RAM is lost once the PC loses power. So you might be wondering, how much data can you store in RAM? So the capacity of RAM is measured in terms of gigabytes. So the advantages of having RAM with higher capacity or RAM with more gigabytes is that the RAM can store a lot of data. So PCs with a lot of RAM or higher RAM capacity are usually better able to cope with multitasking, since multitasking requires a lot of RAM and requires a lot of data to be stored. So right in front of me here is a 16 gigabyte kit of RAM. So each RAM stick is responsible for holding 8 gigabytes of data in this case. So you probably noticed that a lot of old PCs are usually sluggish in performance and they're overall really slow and clunky. So the quickest way to boost performance is to add a lot of RAM. Since old PCs suffer through poor RAM management, adding more RAM to a PC is usually the quickest solution to boost performance and get better RAM management. So the next component in our PC list is the graphics card. So a graphics card is responsible for providing the graphics that you see on a monitor. So most modern day CPUs have a graphics processing unit or a GPU built onto the chip itself. So CPUs that have GPUs built onto the chip itself are referred to as integrated GPU or iGPU, since the GPU is physically integrated with the CPU. So the iGPU is more than powerful enough to push the pixels on your screen or to push the video that you watch on YouTube or Netflix. But the iGPU struggles through performing graphics intensive tasks such as playing high demand graphical games or editing high resolution video or compiling deep learning applications. So right in front of me here is a discrete graphics card. So the discrete graphics card is able to perform all those applications that the iGPU is unable to. So with the use of a discrete graphics card, you can play graphic intensive games, or you can even compile deep learning applications, since deep learning requires the use of a discrete GPU. So the next component in our PC list is the hard drive. So the hard drive acts as a PC's data center. So all your files such as pictures, documents, videos, and the operating system, all of those things reside on the hard drive. So the hard drive acts as a PC's long-term memory. Unlike RAM, which acts as a PC's short-term memory, the hard drive can save data over long term even if the PC loses power. So let's say, for example, you're working on a Word document. You save the file and then you shut down the PC. But then right back when you turn the PC on again, you still have your Word document, which means that the hard drive was able to store your Word document even though you shut down or you essentially lost power. So there are three types of hard drives. You have a hard disk drive, you have a SATA solid state drive, and then you also have an NVMe solid state drive. So we usually abbreviate this as SATA SSDs and this drive as the NVMe SSDs. So the hard disk drive are usually the slowest in terms of read and write speeds, and the NVMe SSDs are the fastest in terms of read and write speeds. And the SATA SSDs fall somewhere between the hard disk drive and the NVMe SSDs in terms of speed. In terms of capacity, the hard disk drives usually come with a lot of capacity, and the NVMe drives usually come with the least capacity. As you can see in this example, this hard disk drive has a 12 terabyte capacity, and this NVMe drive has only 1 terabyte of capacity. The SATA SSD falls somewhere between both of these, since it has 2 terabytes of capacity. So in terms of price, the hard disk drives are usually the cheapest, and the NVMe SSDs are usually the most expensive, and the SATA SSD falls somewhere between the hard disk drive and the NVMe SSD. So the last component inside our PC is the power supply. The power supply is responsible for powering the entire system. The power supply delivers power to the CPU, the motherboard, the graphics card, and other input-output devices such as the hard disk drive and other USB devices. So the power supply is rated in terms of the amount of power or the amount of watts that it consumes. So right in front of me here I have a 450 watt power supply on the left and a 750 watt power supply on the right. So power supplies are basically sold in two different kinds of configurations: a non-modular power supply, which is the one on the left, and a modular power supply, which is the one on the right. So modularity refers to the fact that you can physically get rid of the cables or the power cables that you don't need. So let's just say you are building a PC that doesn't require a graphics card, and you bought a non-modular power supply. So since you bought a non-modular power supply, it comes with all the cables, such as a cable to power the GPU, a cable to power the CPU and the motherboard, physically attached to it. Since your PC doesn't require a graphics card, you still have the cable which is physically attached to the power supply, and there's no way you can get rid of it. So let's just say that you bought a fully modular power supply instead. In a fully modular power supply, you can physically attach the cables to the power supply itself and decide which ones you want to use and which ones you don't. Since your PC doesn't require the use of a graphics card, you can simply not attach the cable for the graphics card in the power supply. So far in the video we talked about what are the components inside a PC. We talked about the CPU, we talked about the motherboard, we talked about RAM, we talked about graphics card, we talked about hard drive, we also talked about the power supply. So now that you have some knowledge about all of these components, you're probably wondering what kinds of PCs you can build with this. So there are basically three different kinds of PCs you can build. You can build a budget PC, you can build an entry-level gaming PC, or you can build a workstation PC. So first up, let's talk about a budget custom PC. A budget custom PC costs somewhere between $350 to $450 US. So users building a budget custom PC are not required to have a graphics card. As you can see in this list, there's no graphics card. A CPU of choice for a budget custom PC is a low-powered CPU which is not overclockable. So overclocking a CPU refers to the ability to push the CPU beyond its base frequencies. As you can see in this example, I have a CPU which is clocked at a 3.6 GHz base frequency. So overclocking this CPU will basically push the CPU beyond the 3.6 GHz base limit. Users building the budget PC are using it for everyday tasks such as web browsing, watching YouTube videos, using office applications such as Microsoft Word, Excel or PowerPoint. In these situations, using such applications demand no more than 8 GB of RAM. The goal of a budget custom PC builder is to maximize cost savings. In order to do that, they usually opt for a hard drive. Since we talked about that a hard drive is a lot cheaper than a SATA SSD and an NVMe SSD, but it's also a lot slower, but it also provides a lot of storage. To save even more money, they opt for a non-modular power supply. So non-modular power supply is a lot cheaper than a fully modular power supply. So we didn't talk about a few items on this list, such as a CPU cooler. A CPU cooler is basically it's a cooler for the CPU, and the case it's really subject. You can go with whichever case that you want. So this whole build comes out to be slightly under $400 US. So now let's talk about an entry-level gaming PC. An entry-level custom gaming PC costs somewhere between $800 to $1,000 US, while the higher-end custom gaming PCs cost more than $1,500 US. So users getting started on building a custom gaming PC should opt for an overclocking CPU. In this case, for example, we have a overclocking CPU which is clocked at 3.4 GHz as its base frequency. So overclocking the CPU would push the CPU well beyond the 3.4 GHz base frequency. So overclocking a CPU produces a lot of heat. Since it produces a lot of heat, we need a water cooler to cool the CPU. An air cooler from a budget custom PC should provide similar cooling functionality, and it should suffice. So the most important component inside our gaming PC is the graphics card. Having a graphics card gives the user a smooth gameplay experience, which would be completely impossible in a budget PC since it doesn't have a graphics card. Since gaming is a memory intensive task, the users should have at least 16 GB of RAM to ensure that they have a smooth gameplay experience and they have no dropped frames while playing the games. Games can add up to be hundreds and hundreds of gigabytes in size. So this is why they should have a 1 terabyte or a minimum of 1 terabyte of hard drive to store all the games, and an SSD to store the operating system and other frequent applications that they use for faster opening and closing times. Lastly, they should have a fully modular power supply, since it gives them the freedom to use the cables that they want and use the components that they want and discard the cables that they don't need. So lastly, now let's talk about a custom workstation PC. So a custom workstation PC costs more than $4,000 US, and it's on the extreme spectrum of a custom PC, utilizing top-of-the-line PC components and also workstation grade hardware. So users building a custom workstation PC opt for a CPU with really high core count. In this case, for example, we have a CPU with 16 cores and it's also overclockable. So a CPU with such a high core count and also being overclockable produces a lot of heat, more heat than a budget PC and a gaming PC. So in this case, a water cooler to cool the CPU is must. An air cooler from a budget PC or a custom PC wouldn't work here. it wouldn't provide enough cooling to cool the CPU. As for memory, a workstation PC uses at least 64 gigabytes of RAM, and this is not the same kind of RAM that's used in the budget PC and a gaming PC. This RAM is server certified, which means that it's a lot faster than the RAM used in a budget PC or a gaming PC. And as for storage, a workstation PC uses NVMe SSDs. As we talked about, that NVMe SSDs are really fast than SATA SSDs or hard disk drives that are used in budget PCs. So this particular configuration has two different kinds of NVMe SSDs arranged in RAID 0. So RAID 0 is basically the type of configuration which allows the operating system to view two separate NVMe SSDs as one entity. So we have a 1 terabyte NVMe SSD and a 2 terabyte NVMe SSD arranged in RAID 0, which would mean that the operating system sees these two separate entities as one 3 terabyte NVMe SSD. So next up we have a video card. So for graphics card, we have two graphics card in an SLI configuration. So an SLI is basically a configuration for having multiple graphics card. Since we have two graphics card, we have a two-way SLI configuration. We can have 3, 4 or 5 graphics cards. It would become a 3-way, 4-way or a 5-way SLI configuration. So to power all of these components, the CPU is really power hungry, the memory consumes a lot of power, and also the graphics card consume a lot of power. We need a power supply with at least 1000 watts to ensure that all the components are being fed with ample power to sustain boosted performance. As you can see, this workstation PC costs slightly under $5,000 US. I've also seen a lot of other PCs or other workstation PCs cost as much as $9,000 US. So those are the three kinds of custom PCs that you can build. You can build a budget PC, you can build an entry-level gaming PC, or you can build a workstation PC. If you are wondering how you can actually build those kinds of PCs, I will attach a document in the video description that would provide step-by-step instructions on how you can build your own custom PC. Thank you very much for watching this video.